Hey guys, welcome to question FM225 of the Further Maths Fortify study guide. Now, this question reads, the system of three simultaneous linear equations above, and we're given these three linear equations, can be written in matrix form as what? Now, to begin this question, I find that it's easiest to convert each of our equations into equations that involve the three sort of elements that we're looking at here. So x, y, and z. So we want to have an x term, a y term, and a z term. Some of you may think, how do we do that when, for example, in this first linear equation, we have an x and a z, but there is no y there. Well, what we're looking at here is we have, in front of that x is an invisible 1, which is multiplying that x. The number that is in front of our y term, you could say that there's a 0 in front of it, because 0 times y would be 0 and it would disappear. So we could say that this is 1x plus 0y plus 1z equals 12. These two equations are still in essence the same, but setting it up with an x term, a y term, and a z term is going to make it easier for us to convert all of this into matrix format later on. Moving on to the next linear equation, we have no x term there, so we're going to say that we've got 0x plus 3y minus 1z, and that's going to be equal to 31. In the next linear equation, we've got 2x plus 4y equals negative 14. So we've got 2x plus 4y plus 0z equals negative 14. This setup makes it a lot easier for us to create the matrix form that we're looking for here. So if we get our matrix ready, we're going to have 1, 0, 1, 0, 3, negative 1, 2, 4, 0. So I've just taken the number in front of each of our x, y, and z terms and plug them into a matrix. I'm then going to set up the next part, x, y, z, and of course this should be all equal to 12, 31, and negative 14, meaning that the correct answer to our question here is option B. If you guys have any questions about how we've done any of this, please drop them in the comments below. Otherwise, I'll see you in the next video.